welcome everybody to MSDOSX week number 4, lecture number 7. So today is talking more about interface builder and in terms of iOS programming, and you're going to see the very similar to OSX development, incredibly similar. In fact, the labs will demonstrate that to a great degree. Next week will be, and so Kevin's taking this one. Next week is testing. We talk about OC unit and OC testing, Send testing toolkit and framework. And then on Thursday we've got delegation, really important concept for Cocoa. Okay. And then I have something to also remind me.
I'll remind you to say it
after the. Cool.
Okay, so I'm going to keep this one really short. This is, like I said, iOS programming is pretty much the same as Mac programming. So this lecture is just going to be kind of talking about what makes iOS slightly more unique from doing Mac development. So it's going to be pretty short to give you guys as much time as possible to work on the Bouncy and the Bouncy iOS lab. The new lab for today, you'll see, is just porting over the Bouncy project to iOS. And as you'll see, it's almost nowhere. It's very little to just have a Mac project suddenly working on iOS. And it's because they're so similar. So I'm just going to start right off and make that same slider UI, but on iOS instead. So I'm going to make an iOS application that just has a single view inside of it. Okay, and you can see that we get pretty much the same files as when we created an empty Mac project. We have an app delegate, just like we have on Mac. And why are you beach balling Xcode? You also get a view controller for the view that's going to get put on screen. We'll talk about what that is a little bit later, but it's a controller object that's managing a view specifically. So we'll talk about that in more detail. And then we have two nibs, one for iPhone, one for iPad. I get two because I made it a universal app. If you just made one or the other, you'd get just one nib. And I'm going to use the iPhone one because it fits on my screen. So if we bring open that objects panel again, we can see that the list is much shorter than it is on Mac. So you've got your text labels, you've got your buttons, you've got a segmented control, which is a control where you can tap through multiple different sections. So we can have a whole bunch of sections, and you can click through and select different elements of this. So you've probably seen those before on iOS. You have a text field. We've got sliders. We've got on/off switches. We've got progress bars and steppers, and a lot of the same things that we have on Mac, but just made simpler. But for this project, I'm just going to drag out a slider. I'm not actually dragging it. And I'm going to drag out a label. Come on, Ivy. Alright, and we'll center align the text. We'll have this go from 0 to 100 again. Starts at 50. And we'll have it send events continuously. Okay, so that's setting up the UI on here. No, not the iPad simulator. Now we can wait for it to attach to launch the simulator, which takes forever for some reason. I should have started the simulator before I ran this. Oh well. And go. Okay, so we've got our slider again. Okay, so okay, so maybe just before I get any further, I'll just kind of give you an overview of the iPhone simulator. So the simulator allows you to simulate an iPad or an iPhone or an iPhone with a Retina display. You can set the version of iOS that it's running, depending on what SDKs you have installed on your version of Xcode. You can rotate it left and right. You can simulate giving it the shake gesture. So, for example, doing cut, copy, and paste. If you want to be able to undo, you can shake to undo. So you can simulate that sort of thing. We can lock it and some other things. Okay, so anyway, we'll go back to our nib. And what I meant to show you last time is how to edit those auto resize properties. And so there's another panel of the inspector here that is, what do they call it? I think they call it the size inspector. So it allows you to program, textually input the width and height and X and Y positions of your elements if you want to assign them by X and Y. And then you can also set the auto resize properties. So again, we have our 4 struts around the outside and our 2 springs in the middle, and then Xcode gives you this nice little preview of, as the window resizes, what would happen. Windows don't really resize on iOS, so it's not a concern about resizing, but as we'll see, it's important when you have rotations. Okay, so like I mentioned, we have struts and springs again on iOS. iOS does not have auto layout. That's a Lion specific feature. And setting auto resizes properties on iOS is really especially useful if you want your application to support auto rotation. So that way, if the user wants to hold it in landscape or versus portrait, they can do that. And pretty much all the time, you can just get the correct resizing behavior or rotation behavior just by setting the auto resize properties. So if we go back to our slider example, if I tell it to stick to the left and right and stretch across the middle, now if I run this and then rotate, you'll see that the slider will stretch to fill all the way across. So if I rotate it now the slider fills the entire width in landscape mode as well as in portrait. Before, if you noticed that it wouldn't resize to the right, it just stuck at that same fixed width and then was stuck in the upper left corner. So setting those properties is really useful on iOS to handle rotations correctly. Okay, so just like on Mac, iOS also has outlets and actions. That's how you can reference your user interface elements and how you have your interface elements send callbacks back to your code. Outlets are exactly the same. Those work exactly like on Mac. You just flag your instance variables or your properties as being IB outlets and then connect them in Interface Builder. Actions are rather more interesting on iOS. And the reason actions are more interesting is that on Mac, each control has one fixed event for which they send an action. So a button has the button got clicked action, or a slider has the value got changed action. On iOS, you can actually send a lot of different actions based on different events. So there's an event for when you touch down. There's an event for when you touch up. There's an event for when you drag inside of it. There's an event for when you, not hover because you don't have hovering on a touchscreen, but and so there's a wide variety of events that can happen on different controls, and iOS allows you to send a different action for every different kind of event that you can receive. Additionally, on iOS, the sender parameter is not required like it is on Mac. So rather than having a separate set target and set action methods like on Mac, iOS has this method add target action for control events. So again, target and action are just like on Mac. The target is the object you want to send the message to when you get an event, and the action is the message you want to send when you get that event. The interesting bit is this for control events parameter. We'll see some examples in a second, but this is what's called a bit mask. It allows you to bitwise OR together a bunch of different values to kind of specify which event or events you want to have this action get fired on. So an example here, we have a button. The common event for a button is when the touch comes up inside the button. That's when you want to actually commit to having the button be pressed. So you might say, tell the button to add the target self, for the action selector, for the control event, UI control event, touch up inside. If you want to, if for example the user cancels the touch by dragging it off screen, or just lets go outside of the button, that probably means they didn't want to actually fire the button. So you can have you can, for example, send a cancel action. And notice here that for the control events, we've just bitwise OR'd touch up outside and touch cancel. The reason we're able to do that is these are all the different control events that are available on iOS. So there's touch down, which is the touch came down. There's touch down repeat for multiple taps in succession. There's drag inside, drag outside, drag enter, drag exit, touch up inside and touch up outside. So that's, if you touch up inside is when the user touches down in a control and then they let go back up inside that same control. Touch up outside is if they touch in the control, move the finger outside, and then let go outside the control. And you can see that these all have different, the bit patterns of these don't overlap. So if you bitwise OR them together, they'll just kind of fill in different columns of the bit mask, and then iOS basically tests each bit based in the bit pattern to determine which control events you're interested in. Does that make sense?
What does that syntax mean with two?
That's left shift. So it shifts the bit pattern up by that many positions. Each successive shift to the left is effectively multiplies by 2. And the details of this, you don't need to worry about what these values are. They're defined by iOS. You just always refer to them by variable names, and if you want more than one, you just bitwise OR them together. Okay, so let's actually make that slider app do something. So again, let's create an action for this slider every time it gets slid. So this project is going to be set up in such a way that the owner of this nib file is going to be an instance of view controller. So if you inspect files owner here, we can see that its class is view controller. Basically, what that means is when this nib loads up, it's going to be, when this nib gets loaded up, it's going to be provided to an instance of view controller, which is kind of all that boilerplate code is done automatically. And so once it's been loaded, then we're going to have a reference to the object that's controlling us is the idea. So that's where we're going to put our logic. So if we want to have an action for when the slider gets slid, we're going to define a method in our view controller. What's the return type if we're making it an action? IB outlet or IB action? IB action. And again, we'll see that Xcode is auto-completing this, telling us that, hey, you're defining a selector for an IB action. So we'll call it, I don't know, slider changed. It takes in an NS slider, or no, not an NS slider. All the UI controls on iOS, instead of having an NS prefix, have a UI prefix. So we have a UI slider. Okay, and then now if we go back into our view controller, we can click on the slider, and if we want, we can either just control drag from the slider to our files owner and select the method. But you might be wondering, which event did that get set for? Because, like I said, there's a lot of different events that UI controls can respond to. They all sort of have a default one. So, for example, the slider, the kind of obvious control event is when the value gets changed, and we can double check that. So if we go to the connections panel, we can see that a slider can send an event for all of these different actions. So editing change, begin, did, end. Well, editing doesn't really make sense because this isn't a text field. But you can have things like the touch comes, if you want to have an event get fired when they start to touch the slider, you can do that. But the obvious one is when value changed. So if we wanted to do that manually, you could also go back to the connections panel and drag from the value changed event to the file's owner, which is the object that's going to receive the message, and then choose the message slider changed. Okay, does that make sense, everybody? Okay, so now let's, again, just for the time being, provide an implementation of that just logs out the value of the slider to the console to make sure that it works. So slider changed. not at sign. Sender value. Oh, and one other thing that I am going to show you that I meant to show you last time is Interface Builder is really smart about the types of the expected types of these actions. So let's break that connection for a second. Let's suppose that instead of UI slider, I'd actually accidentally said UI button. So this is an action for it would expect a button to come in, and Interface Builder knows that a slider can't fire a button action. So you can see that it actually isn't even giving me the option because it knows that there's no method that expects that there's no action that expects a button. So you'll notice that the boilerplate code just puts in id as the parameter type. It's often really useful, especially for debugging purposes, to actually specify the type that you expect, so that way you can't accidentally link the wrong thing. So let's relink that. So value changed. It's going to call slider changed. And notice that the new version of Xcode 4 actually has a little indicator here in the gutter to indicate that this action has been connected to some control. If I break that connection again, then that has an empty hole saying that there's no control that links to that action right now. And so that's a quick way for you to visually see if you've connected the control correctly. Okay, so let's run that with a very tiny console. And I slide the slider, and it is sending me updates. Okay, cool. So next we need a way to refer to our label, so that way we can update the value of the label every time the slider changed. So what do we need? Outlet or action? We need an outlet. Because an outlet is a way for us to refer in code to one of our interface builder elements. So we're going to have an IB outlet of type UI label, and then again Xcode is showing us that that's not been connected. We go to the nib file, we select the file's owner, and we see that it is exporting an outlet called label. We drag it to the label, and now we have a reference to this label object.
Can you explain why it's an instance value instead of
IB outlet's going to be specified in one of two ways. You can either just add IB outlet in front of an instance variable name. You can alternatively declare a property. Is that what you're getting at?
Oh no, just like why isn't it the same syntax as IB action?
Because IB actions are ways for is a method that your user interface can call on your code, whereas an outlet is like is just a way for a variable in your class to refer to an actual piece of interface from your interface builder document. Does that make sense? Does that make sense to everybody? The difference between an action and an outlet, and why you need one over the other? Please ask if that doesn't make sense. Okay, so now in our slider change method, we're going to update the text of the label. And unlike on Mac, we can't just directly set a float value on a text field or on a label. We have to set its text value. So we're going to first construct a string that just contains the float value. String with format %f sender value. Okay, and then we can say label set text string. There we go. There's our first iOS app. Does anybody have any questions about how this demo works? Yeah.
So like, is that like iPhone zip and iPad zip is created with Mac LED, then you gotta connect by separate.
Yeah. So you can the boilerplate code went. I think. Yeah. So if you look at the boilerplate code, it's set up in such a way that when the view controller gets allocated, it looks for a nib that's either iPhone or iPad based on what device you're on. Okay, so I talked about this about NS application for Mac apps. Similarly, there's UI application to manage, which is manages the run loop of your iOS application. It should not wait for mouse events because there aren't any mouse events on iOS, and keyboard events are handled differently. So that's a bug in the slides. And then once it receives an event, once it receives a touch event, it dispatches that event to the object underneath the touch. And it owns the main window nib. So, like on Mac, we have UI view, which is the superclass of all views. Again, like NS views, it has a frame rectangle. You can programmatically add subviews to views. And again, we'll talk about this later, but it's very common to subclass UI view to make your own custom views. UI window is the class of all windows on iOS. Typically, there is one window. Your application has a singular window, and your application lives in that window. You can actually create other windows if you like, but typically there's just the one window. So here's an example of view hierarchy from iOS. It should look very similar to the view hierarchy that we saw in Mac. So there's a window. Unlike Windows on Mac, a window has a single subview that's called its content view. On iOS, a window pretty much is just a view, so it has a subviews, just an array of subviews, just like regular views do. And then that view, of course, has subviews, and then those views have subviews. So UI control, like on Mac, we have UI. On Mac, we have NS control. On iOS, we have UI control. It's a subclass of UI view. That's the superclass of everything that's a text field or a button or a slider or a switch or any of those sort of user interface elements. The difference from Mac, though, is that these don't really... iOS controls don't have an implicit kind of value associated with them. So you can't just ask everything for its float value or its integer value or its string value or whatever. They have really specific values for themselves, and they have their own set of methods for getting out their state. So for text fields, for example, they have a set text property. They don't have a set string value and a set integer value and a set float value. They just have set the text. And so it's up to you to make a format string if you want to put in a number, for example. And again, the documentation of all the controls will tell you what you can do with all the different elements. So my last sort of parting remark is just some design considerations if you're designing for a touchscreen, because this is going to seem like a very obvious statement, but it's actually not if you think about it. When you're designing for a touchscreen, you need to remember that the user is going to be touching the screen. Whoa, big, frightening sounding statement. But it's actually a big deal, because what's the significance of somebody touching the screen? It means that they can't see what's under their finger. So if you have a lot of really small controls, then the user has to be able to, the control is going to be blocked while they're touching it. So if the control changes while they're touching it and their finger is bigger than the control, they won't know that it's been changed. So Apple's recommendation is that you don't make any controls smaller than 44 pixels. So that's the average size of a finger or something. The other problem that's kind of related to that is that fingers are pretty large relative to the XY pixels on a screen. And so there's an inherent error bound on when a touch goes down where exactly the iOS decides the event is centered around. So if you have too many controls that are really close together, the user will have a hard time tapping the one that they meant because there's an imprecision in the actual touching that... and in HCI, this is something called the fat finger problem. That's actually a technical term. Okay, so that wasn't my last thing. I have one more thing. My last thing is about how to design universal apps, which is an application that... So there's kind of three ways you can design an iOS application. You can either make it iPad exclusive, you can make it iPhone, iPod Touch exclusive, or you can make it universal, which is you have one executable that runs on all different iOS devices. which is great for users. They love being able to download it once and put it on all of their different devices. It's a little bit of more work for the developer to be able to support different devices, especially if you want some customized controls. It's often the case that iPad apps, the iPad versions of apps, are more rich in their content because you have a bigger screen. So there's a bit more work on the developer's part to key off of the device, what kind of device you're running on, and do the right thing based on which device you're running. So if you're making a view in Interface Builder, as you saw in the example application that we made here, Apple's recommendation is that you make a nib for the iPad family and a nib for the iPhone family, and then just load the nib, the respective nib based on which kind of device you're on. On the other side, if you are creating your view totally programmatically, that is, you're making all these add subview calls yourself inside of the load view method of your view controller, for example, it should be dynamic enough that it works on both devices. Or do some sort of conditional code path that kind of just does a big if block that's based on which device you're on. So we'll talk about view controllers later, but just kind of as a preview, it's fairly common to have two view controllers, one for iPhone and one for iPad. Again, this can also be done in a single object by just having a bunch of conditional code branches. Okay. Another factor to consider is whether or not the device has a Retina display. Some devices, currently just the iPhone 4 and 4S, have a Retina display where there are twice as many pixels in each dimension. One really great thing that Apple did is that UIKit actually abstracts the pixels away from you, and you have a coordinate system in what they term points. What's really nice about that is iPhone 4 and iPhone 3G, for example, have the same number of points on their screen. They both have 320 wide by 480 tall points, but the iPhone 4S has twice as many pixels. So on those devices with Retina displays, a point is really worth 2 pixels. But you don't really need to worry about that. You just do all of your drawing in points, and UIKit does all the rendering correctly based on the pixel density of the device that you're running on. And right now it's just 2, but you can imagine in the future if we have multiple devices with different resolutions, they can just set a different scale factor, and then everything should just continue to work. So one thing to consider if you're designing for a Retina display is that you should have, and if you have images, that images on the Retina display need to be twice the resolution. So a common way to do that is to make 2 versions of an image. One, say that's 30 pixels by 30 pixels, and another version that's 60 pixels by 60 pixels. And then that way, when they fill the same space on the screen, on the Retina display, it will have twice as many pixels in each direction, so that way it will get correctly rendered without any fuzziness. And the convention is that the enlarged image, the name just ends with @2x. And what's really neat is the method UIImage named. If you're running on a Retina device, it automatically looks for one with @2x at the end. If it doesn't find it, then it just uses the regular name. So you don't have to add your own. If I'm on a Retina display, then look for 2x. If I'm on not a Retina display, then just do regular. Image named already will do that for you, which is really, really nice. So like I said, UIKit actually automates a lot of these different screen resolutions, device properties. Occasionally, you'll have to do things manually. So here's a few things that are useful for determining some of these things. So there's a macro UI user interface idiom that returns either UI user interface idiom pad or phone, based on if you're on an iPad or if you're on an iPhone or iPod Touch. And then you can also ask the UI screen class for its scale value, and that will tell you the scale factor between pixels and points. And right now it's either 1 if it's on a 3G, 3GS, or 2 if it's on a 4 or 4S. Okay, any questions? Like I said, I wanted to keep that short so that you guys can have as much time to work on the lab, because I think doing things hands-on is the best way to practice making interfaces. So Glenn wanted to talk about something.
Yeah, so the 2 labs, the first lab has you build an OS X application, and then the second lab has you port it over to an iOS application, which took me 20 minutes to do. But the writing up the lab took a couple hours. There's a problem in there with with some of the instructions that have to do with, or some of the demo code that has to do with the colors, NS color versus UI color. I'm having trouble tracking that down exactly where that's at, mainly because I've got like 8 or 10 versions of this project in different stages.
So if you get to those instructions and you're not sure, let us know so that we can...
Yeah, so that I can fix that, please. And it's pretty glaringly obvious. I mean, places where it's not going to compile or link, there's specific instructions on tracking down why it's not compiling and linking, just for edification purposes. But there's one problem trying to compile where it's trying to use NS color when it should use UI color, and I'm trying to figure out which step that's on, and I'm failing. So if you get to that step, please pause for a second and let me know, and so I can fix it. Cool. And if you popped open the lab while Kevin was talking, and you tried the Bouncy iOS lab, and you tried to download it, the link was broken. It's been fixed. So the starter project is there.
Okay, cool.